Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Zain Ali bin Abdul Salim. Today I will present about the pharmaceutical wastewater. Nowadays, pharmaceutical industry around the world have subtly produce a harsh amount of pharmaceutical waste. This will become one challenge to other researchers and scientists to overcome the threat. Pharmaceutical wastewater is referred to as the effluent and waste generated during the manufacturing of the pharmaceuticals. Pharmaceuticals are generated from hospitals and households just as unused medicines. The wastewater includes the pharmaceutical industry as well as from the houses and hospitals that can contaminate the environment. To handle the pharmaceutical wastewater, is highly changing the nature due to the composition of the raw material varies widely from one class of product to another. The next problem is some industries continues to release the pharmaceutical wastewater to the environment. This is because they use pretense to escape from the regulation of stringent pollution control norm. There is some calculation of pharmaceutical industry for wastewater according to their source which are municipal wastewater, spent liquor for the fermentation process, chemical waste, concentrate waste from evaporation and flow, and laboratory washing waste. The development of the biotechnology, pharmaceutical products contribute to chemical discharge uses as ancillary substance like buffers, chelators, and antibiotics into the aquatic environment. So, the main component of the pharmaceutical wastewater is pharmaceutical active compound, also known as PHACS, which are the most toxic component. Pharmaceutical active compounds are a complex molecule that can be polarized in nature with a molecular weight from 200 to 1000 Da. It's widely used in specific biological activity, which aids in the application of the drugs. Pharmaceutical waste may be divided into two categories. The first category is waste generated by the medicinal companies and the secondary waste obtained from the treatment cycle plant. The second is medical waste from the hospital and the domestic sector which substantially contaminate the sewage system. That's all for me. Thank you.
Assalamualaikum, Ibu Puan Nila Eliana. My name is Alif Shakir Besata. Today I will present about the implication of pharmaceutical wastewater produced towards ecosystem and society. In a society where nearly 70% take at least one prescription drug and the pharmaceutical and biochemical industries spend billions of dollars each year to create a new product, it is no surprise that a large amount of pharmaceutical wastewater is produced each year. But what happened to this wastewater, and what impact does it have on our society and environment? Firstly, the impact towards our society is in United States. For example, humans are exposed daily to both pharmaceutical and xenoestrogen, which have been implicated in various human health outcomes such as testicular degeneracy syndrome and testicular cancer and breast cancer in women. Other than that, like other environmental issues, pharmaceutical pollution more directly and seriously affect those living near production plants whose water and food sources are contaminated with waste from the pharmaceutical production. Next, the impact towards environment. One of the main threats is that Discharging pharmaceutical waste, for example antibiotic, into the environment can promote the natural development of antibiotic-resistant pathogens that are harder to treat. This impact will cause the pathogen becomes more dangerous and will impact the health of human and environment. Then, the other impacts toward environment is the waste produced can have adverse reproductive effect in aquatic life through sex reverses, production of intersex individual, alteration in mating, and prevention of gonadal maturation. For some times, evidence have been mounting that chemical pollution may be entering the food chain and altering sex function of fish. But this effect may not be limited to the fish. Research suggests that exposure to pharmaceutical and other chemicals in drinking water may affect human reproductive system too. Although research has shown that pharmaceutical wastes are present in water bodies throughout the world, no study has shown a direct effect on human health. However, the absence of empirical data cannot rule out the possibility of adverse outcome due to interaction or long-term exposure to this substance. Because the amount of this chemical in water supply may be in part per trillion or part per billion, it is difficult to chemically determine the amount present. Many studies have therefore been focused to determining if the concentration of this pharmaceutical is at or above the accepted daily intake, at which this desired biological outcome can occur.
Assalamualaikum warahmatullahi wabarakatuh. I am Aizadin Akmal bin Wafaralo. I will now show you the process technology involved in pharmaceutical wastewater treatment. So this is the overall diagram for process treatment of pharmaceutical waste. So there are three types of technology occurring here, which is pH treatment, chemical precipitation, and sedimentation, and then rinse and repeat. So pharmaceutical waste tank, it is where the pH is treated, which will then after being treated, the influent will be chemical precipitated in order to remove the chemical waste, and then sedimentation occurs. And then after the sedimentation, effluent is done. The effluent is then treated for its pH for a second time, and the chemical precipitation for a second time, and the second time of sedimentation as well for uh, effective treatment of pharmaceutical waste.
Assalamualaikum warahmatullahi wabarakatuh. And my name is Muhammad Amir Fitri Madlan, and I'll present to you the process flow of pharmaceutical wastewater treatment. First, the pharmaceutical wastewater will enter through the inlet into the treatment facility. Then, it will store temporarily or longer in the receiving tank facility. After that, it will be enter the pH adjustment. pH adjustment is where the application of acid base of pH adjustment will be done. If the pharmaceutical wastewater is too acidic, addition of alkaline will be done until it neutralizes, and vice versa. Then after that, it will go to the chemical precipitation. First, coagulator. Chemical precipitation is where the addition of alum or aluminum sulfate is added to clump together the free particles, the suspended particles. Then, then after that, it will go to the sedimentation tank. Sedimentation tank allows the suspended particles to settle out of wastewater as it flows through the tank. Then it will have the enter activated sludge. The process involves of blowing oxygen or air into raw and unsettled sewage. The sewage is bubbles and discharged into activated sludge chamber. The clean water is discharged into watercourse. Uh, uh, After the sedimentation tank also, it will have the chemical precipitation for the second coagulator. Chemical sedimentation for coagulator is the extent of the first coagulator, but the removing of the remaining particles. After that, it will go to the sedimentation tank again for the second time, or also known as settling tank, which has the same function. It allows suspended particle to settle out wastewater because it flows slowly through the tank. And lastly, uh, is sludge dewatering. Uh, Sludge dewatering is the separation of liquid and solid phase. Is applied by the least possible residual moisture is required in solid phase, and also vice versa. And lastly, inlet or effluent or disposal. The disposal must be same as the standard set by the EQA in terms of VOC, PHAC, BOD, and COD. And that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Asfar. So today I will explain to you the advantages of this technology towards society and environment. The first benefits of this technology is the removal of high content of organic matter, like a large part of which is uneasily biodegradable compounds like alcohol, acetals, and others. Next is a slowly biodegradable organic compounds like aromatic compounds and chlorinated hydrocarbon. Then it will remove the toxic compounds like antibiotic. And the last one is the soaps and surfactant detergents that will harm the society and environment. The next one is the advantages of this technology in terms of the removal of waste consisting of drug residue with high demand of COD, BOD, and pharmaceutically active compounds like hormone, antibiotics, toxic substances, which are not treated properly. So many of these substances they are stated just now uh, explain to you how serious these substances which can pose a threat to human health. So these substances need to be removed as soon as possible to sustain the environment and the society. And the last one is in terms of living, this technology can save the aquatic living because all the substances uh, flow to the water and river. So this wastewater treatment plant can treat the wastewater uh, to to make sure that the aquatic living is not negatively affected, because from the research we can see that some anti-inflammatory drugs have been shown to damage the fish gills and lung. So some hormones or compounds that mimic hormone properties are capable of feminize and masculinize them and pose a threat to their population. So that's all from me. Thank you.